Most MotoGP fans will be familiar with the concept of changing gears on a regular motorcycle, using the clutch lever and the gear shifter to go up or down through the gears. But on a MotoGP bike, the technology is slightly different and that little bit more advanced. And it has to be because these guys change gears sometimes up to 500 times per race, if not more. But it's not going to be me who's going to explain it to you, it's going to be the guys at NGM Mobile Ford Racing who are going to show us exactly how the transmission on one of these bikes works.
Main components of the powertrain of the MotoGP bike is composed essentially by clutch and gearbox. We have the clutch, here is the lever for command the clutch. The clutch is inside of this side of the engine, and all the gearbox is inside the engine, and the exit from the power is here where is the front pinion. Normally on the street bike the first gear is down and all the gears are up. But on the race bike, everything is opposite because the rider needs to be able to change gear also when is in the corner. So the first gear is up and all the gears are down. There are some circuits where we use more gears, but normally it's around 500 and 800 gear shifting during a race. In upshifting, normally the rider keeps full throttle and just press the pedal. During this process, when the rider starts to press the pedal, this load cell reads the pressure, so they cut the current, so there is no power transmission between the engine and the gearbox. And so we can shift gear without pulling the clutch. This is very important because when the rider makes like 600 gear shifting during the race, this is less job for him. He can concentrate more on the driving. In the downshifting is the opposite. The rider keeps the throttle completely closed and downshift, pressing the pedal in this direction. In this moment, the electronic say to the butterfly to open, so it's like if the rider make this movement with the throttle, and this allows the gears to enter in downshift. If you don't match the revolution of the engine, because when you shift down the gear, you need to disengage a gear and engage another gear. If there is the power transmission or the difference of the speed between one gear and the other is too big, when you try to engage the gear, it doesn't engage or you can damage the teeth. The gearbox has 6 gears, and for the rule, we can only have a total of 24 options. So we have 24 options to switch the gearbox to the track and to the rider's wheeling. We change the number of teeth of the 2 gears because every gear is composed by 2 single gears. We can change the teeth of the gears to make the gearbox shorter or longer, depending on the track, depending on the rider style, and also depending on the engine character. When we know the layout of the track, we already know which is the speed we are supposed to have in every corner. And so we know which gear we will use in that corner. The slipper clutch, the main aim of the slipper clutch is to avoid the lock of the rear wheel in braking. There is 2 ways to avoid this. One is with the mechanical side, so with the anti-slipping clutch, and another option is by electronic. The clutch is composed by 3 pieces. 2 of these pieces can rotate and move forward. So when the torque is coming from the wheel to the engine, the clutch can open, and so we don't transmit the power to the engine. So the tire is more free to roll and is not locking.